Hello, everyone, and welcome to the day 4 or session 4 of our AWS Solutions Architect Associate Certification Bootcamp. This is week 2. In the previous 3 sessions, we had introduction to AWS and cloud, and we also talked a little bit about S3. And in yesterday's session, we did a deep dive on all of the compute solutions on AWS. So if you haven't had a look at those, please do once this session is done. So in today's session, we are going to look at all of the AWS serverless services, things like Lambda and API Gateway and many other serverless services. So to do the session, today we have Kaustubh. So Kaustubh, if you can go ahead and introduce yourself and take the session away.
Yeah, sure. Thank you, Faisal. Today I'll be presenting AWS serverless services. So we'll be going through, first of all, we'll be covering what is the concept of serverless, what exactly it means. And after that, we'll be going through a few of the serverless services which are provided by AWS and the ones that you typically use in a serverless architecture. So we'll be covering AWS Lambda, Amazon API Gateway, Amazon SQS, Amazon SNS, and AWS Fargate in today's session. Let's start with first understanding what is serverless. There are multiple keywords listed here, and even during the exam, these keywords would help you identify that a serverless architecture is what's required as the answer. So, I'll go through each of these keywords and explain what they mean and how they relate with the concept of serverless. So, first we have short running. So this means that serverless is used for tasks which execute only for a short period of time. Usually this can be like in milliseconds or maybe a few seconds. Usually won't go longer than a few minutes at most, each request. Stateless is another important concept. So, serverless architectures can have state in the form of databases. It's not like they don't have state at all, but each individual request itself is stateless and is handled separately. And next, we have event driven. So, the serverless execution happens in response to a specific event. So, as we'll be seeing in the demo further going on, uh, we would be triggering serverless services like Lambda, SQS, or things like that through events. And we'll be demonstrating that. Next, we have auto scale on demand. So this is similar to almost all cloud architectures. You would have auto scaling. That's basically like a basic requirement in today's world. Whatever architecture you're deploying, it needs to be able to scale on demand. And the next point we have is sort of related, as in the billing model is pay for use. So you might think that even let's say EC2 or ECS or the other services that were covered yesterday are also pay for use, as in you're only paying for the virtual machines you are deploying and things like that. But the difference in serverless is that there are no servers provisioned or capacity provisioned as such. So pay for use here means you're only paying for the execution time. So we will be seeing this in a bit more detail when we go through the Lambda billing model. But you can think of it as you're only paying for the execution time and not any capacity provision cost. And this is the last 2 points are quite important. The one of the main benefits of serverless is that you are eliminating the infrastructure management task. So suppose if you use EC2 to deploy your application, then you will need to manage the virtual machines that you are deploying, and make sure that they are updated and patched. So AWS Lambda eliminates that need, since you only define the code and it's executed automatically, or you are using managed services where you are not deploying any servers or anything like that. And the last one is also interrelated, as in instead of focusing on the infrastructure management task, you would be focusing on actually writing the business logic or the code. So that becomes the key of your application architecture and not the architecture itself. So to better visualize this, you can take a look at this graph, wherein you can see how with EC2 and services like ECS and EKS on EC2, you have a focus on operational maintenance, as in you are focusing on the uh, infrastructure management, as we already discussed. While with serverless services like Lambda, you will be focusing on application logic. So yesterday we already covered this part: Amazon ECS, Amazon EC2, Amazon EKS, and specifically for ECS and EKS, it was on EC2. Today we'll be covering Fargate as well. So Fargate is like you can say one of the launch type of ECS and EKS. It's integrated with both of this. So we'll be taking a look at that, and then we'll be also looking at Lambda, which is like the poster child, or you can see the main serverless offering by AWS, which usually is at the heart of all serverless architectures. So I'll move on to the next part. Yeah, before I do that, are there any questions? You can post any questions you have in the chat. Okay, I'll move on to the next part then, which is AWS Lambda. So a lot of the focus on of today's session would be on this service, and we'll be seeing how Lambda also integrates with the other services we'll be covering today. So Lambda is a serverless compute service. So it's basically focusing on the execution of a small snippet of code, uh, and it has all the features of serverless which we have covered already. It's short running, it's stateless, it's event driven, it's auto scale on demand, it's pay for use. uh, you don't have to manage the underlying servers or anything like that, and we'll be focusing on writing the code and not infrastructure management. So uh, I'll share my uh, console screen, and I'll be sharing my console screen and doing a demo of AWS Lambda. Post that will be, I'll come back to the question asked on uh, voice-based solutions in serverless.
Yeah, so Kaustuv, there is a question
Yeah.
like AWS User Group India says that any sample code for using AWS serverless service for voice-based solution like AWS Echo and Alexa and thanks. He's asking some
Okay.
question.
Okay.
Yeah.
So, okay, can see in the follow-up, he has also mentioned Kubernetes. So, uh, in Kubernetes, if you want to focus on serverless specifically, there is a option to integrate Fargate with EKS. So you can launch an EKS cluster and run your pods on Fargate. So that way you can combine serverless with Kubernetes. And if you want a non-Kubernetes solution, you might be able to integrate AWS Lambda as well. So, okay, I'll move on to the demo for the Lambda part. So, okay, I'll focus on creating a function first and going through all the configuration options which are provided for AWS Lambda. And then we'll do a demo of how AWS Lambda integrates with the different services. So, okay, I'll first go back to the main console. So from here, you can go to AWS Lambda. You can uh, type Lambda in the search bar here and just click on Lambda. This will take you to the main Lambda console. I'd already deployed a function previously, but for this demo, we'll be starting from scratch. So here you can just add some basic information for the AWS Lambda function. So here I'll just put a name for the function. You can select the runtime that you want for your Lambda function. So these are the latest supported runtimes: .NET, Go, Java, Node, Python, UB. And there are also some other old supported runtimes. So apart from using the predefined runtime, there is also an option to specify a container image in AWS Lambda, and that also you can use to build a Lambda function. So instead of using the runtime provided by AWS Lambda, you would define a Docker container image and run your code inside that. When we go through the Fargate section, I'll further delve into how this would be different from using Fargate. So coming back here. So we'll be defining a very simple Python function. You don't need to know Python to follow this demo, since we are not going to use any advanced functionalities. So you can also change or create a default execution rule. So execution rule is basically used to define the permissions that your Lambda function has when it executes. So at the very least, it's recommended that you create a IAM role which has access to push logs to Amazon CloudWatch, so that you can view the logs of your AWS Lambda function. On top of that, if you are integrating with any other service and you might, if you want to interact with that service from your Lambda function directly, you might want to add further policies to your IAM role, which we'll be seeing further in this demo. So for now, I'll just go with the default option of creating a new role with basic Lambda permissions. Okay, the Lambda function is now created, and it has been deployed. So if you create it from the console, this is the default code you get. Basically, you don't have anything. You just return a status code of 200, and you return a hello from Lambda message. So there are multiple configuration options that we have to look at here. So I'll be first going over the basic configuration and then going through all the advanced configuration that's given here. So first of all, you need to cover the runtime settings, the handler, and the architecture. So the architecture was something you could customize during creation as well. So there are two options here. Either you can choose x86 64, which till recently was the only architecture available, and ARM64 was added recently. So this would change the pricing, the price that you are charged for your Lambda function, and obviously the architecture you're using. So ARM64 is currently slightly cheaper, but based on your requirements, you might want to keep it x86-64 and change it to ARM64. The other option here is the handler. So to illustrate that, I'll just show the code as well. So here, as you can see inside the code, there is a single file lambda function.py. So you can define multiple files here as well. And but the entry point for the lambda function would be a single point. So in this case, it's lambda function, which is the file name, dot lambda handler, which is the function name. So this means that whenever the AWS Lambda execution starts, this lambda handler function is called, and in that you pass the event and the context. So this is passed by the Lambda service itself. So we'll be looking at what are the contents of event and context in some time. But it's important that you get the handler name here correctly. If it is wrong, all your Lambda executions would fail, since the Lambda runtime won't be able to find your Lambda function entry point. Instead of editing the code through the console, you also have the option to upload a zip file, or you can specify a or S3 location where the zip file is stored, and you can deploy a function that way. So if you have a complex Lambda function which has a lot of lines of code, you might want to upload a zip instead of trying to edit it from the console itself. One thing I forgot to mention, the handler here can be customized, like the exact format is customized according to the runtime you are using. So in the case of Python, it would be file.function name. And next we have the layers part. So for Lambda functions, we can have Lambda layers defined, which are used to specify the dependencies for your Lambda function. So suppose, okay, in the case of Python, you might want to use a third-party library which is not part of the standard library. So say something like NumPy, or maybe some uh, ML library or something like that. If you want to use, you can create a layer of that, and that also is created in the form of a zip which you upload, and then you can add that layer to your Lambda functions. You can use the same layer in multiple Lambda functions, and you can also have multiple layers in the same Lambda function. So if you have, say, 5 dependencies, you might have 5 different layers for each and add them to the required Lambda functions. So any questions, guys, before we move on to the next part?
Yeah, we can proceed with the session.
Okay. Yeah, I see there are no comments. Okay. So, okay, I'll move on to the configuration here. So, the general configuration, okay, so this is also an important part of the AWS Lambda function configuration. So, here you have the memory which is allocated to the Lambda function. So, as you can see, the CPU, like you cannot specify the vCPU for your Lambda function. This is because it's proportional to the memory you have configured. So higher the memory, higher the number of vCPU is allocated. And this means that this not only controls the amount of memory that is available to your function, but also the amount of CPU power which is available to your function. Uh, the next part is the timeout. So this is quite crucial. So as I had said, that Lambda, like in general, serverless is used for short running tasks. So it can be up to a few milliseconds or a few minutes. So this determines the maximum amount of execution time your Lambda function has. So uh, suppose if we have a task which takes say 5 minutes for the Lambda to execute, then you will need to set a higher timeout. Otherwise, the Lambda function execution would be stopped in between and you will get an error. So currently it's a maximum of 15 minutes for AWS Lambda. Although generally you might want to start looking at other options if you feel that your execution is reaching a time of 15 minutes based on the use case. Uh, Ideally, the timeout would be quite low since usually in serverless architecture, the focus is on short running tasks. So here we have the execution role. So I already described this when we were creating the Lambda function. You can change the IAM role attached to the function post the creation of the Lambda function as well. So triggers is one more important part of the Lambda function. They define how actually your Lambda function would be executed, as in when the execution would be triggered. So we will be adding a few triggers as we go on through the session to the other services, and we'll come back to the section then. So permissions is you can say a utility AWS provides on the console. So it's just a role that we already attached to this function, and you can view the uh, permissions of that role. So as I described earlier, by default, like it would create a role with CloudWatch logs permission, since that's the minimum you require to for the Lambda function to be able to send the logs of the function. So destinations, we won't be going into detail into this, but it's something you can use to track whether your function got executed correctly or not. And like for each execution, you can log it into, let's say, SQS queues or SNS topics or other such services. So environment variables is something like you would understand if you have some programming experience. So whenever you are writing code, generally you don't want to like hard code any secret values or even any configuration related values. So things like say the database host name and other stuff, or you don't want to hard code that. So you can use the option here for environment variables, wherein you can specify the key value pairs, and this values can be read in the function. So the exact code for that would differ according to the programming language, but these values you can read in your code. So in this way you can use the same piece of code in multiple different environments. So let's say if you have the same Lambda function defined in dev and production, then you can use the environment variables to uh, uh, configure things like the database host name or the password or things like that. So in general, for things like secrets, like say database passwords, you might also want to look into services like secrets manager and parameter store. So I won't be covering those now, but apart from the non-secret, so non-secret values, though you can store in environment variables itself, you don't need to use secrets manager or other services. So the next thing we have here is tags. So this is something you will see in each AWS service, and almost every resource you create in AWS has this option to add tags. So I'm already sure that that this has been covered in previous sessions, but to just give a quick recap, this is a way you can use to search your resources, filter them, and it also can be useful to track your costs, since you can group your task according to the group your cost according to tags which are added to each resource. Next, we have the VPC option. So this is completely optional, but if you have a Lambda function which you want to run inside a AWS VPC, then you can configure it here. So you will have to choose a VPC, and you'll have to choose the subnets inside that, security groups, and other networking configuration. So this can be useful in situations where, let's say, you want to access a private resource which is only accessible inside the VPC from your Lambda function. So generally things like databases which you don't expose publicly can be configured if you have the VPC configuration enabled for your AWS Lambda function. So before I move on, are there any questions in the chat? Even when I'm speaking, you can post any questions you have in the chat, and like when I come back here, I'll directly answer the questions.
Yeah, Kaustubh, no questions
So
as of now.
yeah, so uh, I'll move on to the next part, which is okay, monitoring and operating tools. So okay, I'll just use the monitor screen, like tab here. That would give a better idea. So whenever you define a Lambda function, it automatically uh, uh, like the configuration for CloudWatch based monitoring is already configured for you. So whenever the Lambda function executes, you will be able to view the logs in CloudWatch and view the metrics for whether how much is the error count, how much is the success rate, what was the average duration. Things like that you would be able to view here as well as in the CloudWatch console. So we'll be viewing some sample execution logs later in the demo. So next we have the concurrency of the AWS Lambda function. So there are multiple ways to configure this. So you can have provision concurrency. So I'll be covering that later. But for now, uh, just focus on the function concurrency part. So the basic concurrency. So there are two options here that, as you can see. So the first part is use unreserved account concurrency. So by default, each AWS account has a maximum of 1,000 AWS Lambda function concurrency, which means that at a single point of time, a maximum of 1,000 Lambda functions can execute. So uh, you can either use the account level concurrency, or you can reserve your own uh, like concurrency amount of concurrency for the specific function. So in general, if you know the workload for your Lambda function, it's recommended that you specify the concurrency here so that you don't accidentally go over the concurrency and maybe get charged extra if you weren't expecting it. Or you can just use the unreserved account concurrency. Whenever you reserve concurrency, it's taken out of your account pool, so keep that in mind. So any other Lambda function that I configure after this would only be able to use 994 concurrency if it's using the unreserved account concurrency. And the next part is the provision concurrency. So this is a problem with you can say serverless architectures like AWS Lambda. So you can have something called cold start, wherein if you haven't invoked your Lambda function for a long time, then it would the first execution would take some time. So this is because behind the scenes Lambda uses Docker containers, and uh, at the first invocation it would uh, basically create the Docker container quickly, and post which you would be running your Lambda function code in that container. So once the first invocation is done, that a container would be kept for like it can be roughly 30 to 45 minutes. It's not a like a defined in the documentation. But in general, this can be a problem where you have applications where you require low latency. It can also occur if your Lambda function is scaling up. Since suppose if you have 3 concurrent executions going on, then you would require 3 containers running in the backend, which is managed by AWS. So to avoid such scenarios where you have cold starts, you can have provisioned concurrency. So this has extra cost uh, associated with it if you are provisioning concurrency. In general, if you feel like this is not required for your use case, you can just skip it and just use the unreserved account concurrency if you don't want to go into the fine details here. So this is basically related to asynchronous invocations. So it depends on the type of triggers you are defined and other stuff. So I won't go into detail here. Same for code signing. So this is something you use to verify that the code that is defined in your Lambda function is authentic and hasn't been changed since you have last signed it. So I won't go into further detail here. One more thing to note here is generally in the AWS console for a lot of services, you can see something here called info. So if you don't want to go into the documentation for something, you can just quickly click on this and view what it means here, which might save you some time. So there are a few additional features here, things like database proxies, which are used to configure connections with database. So this was a relatively recent feature. I believe it was added in 2019 or 2020, wherein you can configure a proxy for your database. So if you have a RDS instance in your account and you want to connect to that through your Lambda function, you can create something called database proxy, which would basically create a pool of connections which would be managed by AWS Lambda, and that would simplify connecting with your database. You also have the option to integrate EFS, which is basically file systems, with your Lambda function. So your Lambda functions can share the same file system with other functions or even other services like EC2. And finally, you have the options to configure state machines for step functions in AWS. So are there any questions? Okay, I can see there are no comments yet. So I'll move on to the next part, which is testing. So so we already have some basic boilerplate code defined here, which just returns a sample hello from Lambda response. So I can quickly test this code. So in the console, there is the test option wherein you can configure sample test events. So here I'm creating a sample event and I can test it. And as you can see, this was the sample, like the response written by AWS Lambda. And there are no logs as such. It just showed the start and end. So this is because there is no code here which prints anything or logs anything. If you add that, you would be able to view whatever you're sending to std out in here in the CloudWatch logs. So one quick thing to note here, if you notice carefully, it shows the duration for which the Lambda function executed and the duration for which you are billed for that Lambda function. So Lambda, AWS Lambda provides millisecond granularity. So if your Lambda function executed for, let's say, 1.33 millisecond, then you would be billed for 2 milliseconds. And suppose if it executed for say 29.25 milliseconds, it would be built for 30 milliseconds and so on. And it also shows the memory size which was allocated for your function and what was the actual memory used. It's important to note that you would be charged for this figure even if like the Lambda function did not fully utilize this memory. So make sure that the memory size is configured optimally. So I'll here in the Lambda function, I'll change the code a bit. So here I'm just using some code I typed out earlier. So I'm just like added a few things here, which is instead of printing a hello world message or like sending it as response, you are sending the event as a response, which was provided to this Lambda function. And I'm also printing the event and the context, so you can view it in the CloudWatch logs. One important thing to note here is that just changing the code here in the console does not actually deploy it. You need to click on deploy here, and only post that you will be able to test it. So okay, I'll go to okay. So this is one thing I had told you guys about before. You need to configure the handler correctly. So here, as you can see, the file name is correct. Obviously, I did not change that. It's a Lambda function, but I changed this to handler. So as I had mentioned earlier, this would fail all AWS Lambda invocations, and you would get this handler not found error. So whenever you get this error, you need to check the value of this parameter here. So we would just quickly change this to lambda function dot handler. And now we can test it again. As you can see, it's now succeeded. And since this was the sample, the event that had provided to the Lambda function, this is what it's receiving. So this is the event parameter and this is the context parameter. So the context parameter is generally not something that you often use. It's provides details of the current Lambda environment and things like say the log group name or how much memory is allocated, things like that. Generally, you only use the event parameter in your application logic. So we would be coming back to aliases and versions further in the session. But before I move on to the next topic, which is API gateway, are there any questions?
Yeah,
Okay.
there are no questions as of
Questions,
now.
yeah. Yeah. Okay.
Yeah, we can move ahead, Kaustubh.
Yeah. Okay, so let me reshare my presentation. So this is one sample architecture you can have in AWS Lambda. So you can have S3 based trigger. So S3 is something which was already covered. So I assume you guys are familiar with it. So whenever you upload an object to S3, you can configure a trigger for that in AWS Lambda. So whenever that object is uploaded, the Lambda function would trigger and you can have your own custom logic here. So in this case, this architecture would process the photo which was given and resize it, and you can resize it into different sizes according to the screen on which the image should be used. So this can be useful in architectures like say image upload website. So therein once the user uploads the image, then the Lambda function can automatically trigger and resize it into different sizes, which then the user can view and use. So for the pricing, I'm not covered it in the slides here, but what you need to know is the things which I mentioned earlier. Execution time, memory are the main key factors to decide your pricing. The amount of memory you have allocated and the amount of time your Lambda function executes uh, it decides how much you are charged. And the overall pricing for Lambda is very cheap. So and you also have a perpetual free tier, which means that even beyond the initial 12 months of your AWS account, there is a certain amount of Lambda invocations and execution time which is free. So I would encourage you to check out the pricing, and like you can play around with AWS Lambda free of charge up to a certain extent. So I'll move on to the next topic, which is Amazon API Gateway. So this basically creates a publisher. So this is used to create a front end for, you can say, like a how do I describe it? A door for your application programming interface. So whatever APIs you want to deploy, you can have this as the entry point for those, and this would then send forward the request to your application. So the actual logic of your application can be uh, in different things. So as you can see here in the diagram, you have the API gateway in front, which acts as the front door for your application. It has some useful features like caching, so you don't execute the same request again and again. And you also have logging and monitoring through CloudWatch in API gateway. So whatever client users you have for your application, they would be accessing your application through uh, the API gateway, and then it would forward your request to whatever integrations you have configured for your API gateway. So it can be AWS Lambda, which we saw. It can be EC2. It can be Kinesis. It can be DynamoDB, and there are also other AWS services available. You can also integrate with private applications which you have on your on-prem systems. So this is a sample architecture you can have in API Gateway. So here you make a request to API Gateway, and then API Gateway can be integrated with any backend. In this case, it's AWS Lambda, and this would run the code required for your request. So in this case, suppose let's say it's an application like say Instagram or Facebook or anything like that, and you have posted an update on your profile, then this Lambda function would run, and it would automatically send an update to each of your friends on that social media app, and that update can be sent through Amazon SNS, which we'll be viewing further in this session. Or you can write any custom code logic you want here and integrate it in whichever way you want. So API Gateway has different types of varieties, you can say. So you have the conventional RESTful APIs, and you also have something called WebSocket APIs. So this is used in applications like say live chats or gaming, where you want to have a persistent connection between the server and the client. And this connection would be bidirectional, as in the client can also make calls to the server, And so for example, in a chatting application, when you send a message, if it's a WebSocket API, you would be the client, and you'll be sending messages to the remote application. So I won't be covering this in detail. For today's session, we'll be focusing on RESTful APIs. So we have HTTP APIs and REST APIs. So this is a, like you can say, can cause a bit of a confusion for folks who are new to this, that AWS provide two types of RESTful APIs: HTTP APIs and REST APIs. So like if you go to the difference, like the documentation, and view the difference, it's quite a long list. So you can go through that, but in general, you can remember it this way: HTTP APIs only provide, like in general, provide the proxy functionality part, as in whatever requests are coming in would be sent to the backend integration, and REST APIs provide that, and it also provides some additional API management features. So things like, say, logging, monitoring, and like say API key based authentication and stuff like that. So in general, REST APIs have more features than HTTP APIs, but this is not a hard rule. There are a lot of features which are only supported in HTTP APIs. So so this is just a general guideline. And another difference is that HTTP APIs are meant for basic functionality, as in if you want to have low latency responses uh, to all API calls, and you don't want to do some advanced configuration at the API gateway layer, then you can use HTTP APIs. Otherwise, you can use REST APIs, which have more functionality. So relatively higher means it's the latency is higher than HTTP, but it's still quite low. I mean, it's still in milliseconds, so it's not like this has a lot of latency, and it has some slightly higher cost compared to HTTP APIs. So for the demo, we will be focusing on REST APIs. Uh, you can also try creating HTTP APIs on your own and test those, maybe integrated with AWS Lambda functions. So, okay, I'll reshare my screen. Okay, I see there are no questions posted, so I'll directly move on to the next part. So, okay, instead of creating the API gateway through the API gateway console, I'll try a slightly alternative approach. Since there are already multiple tutorials covering that, we can go for a slightly different approach here. So instead of creating the API gateway through the API gateway console, I'll create it through the Lambda console. So here I can specify, when I go to the Lambda console, I have an option to add triggers here. So for my Lambda function, so here I'll add API gateway, and here I can specify the API. So you can either configure it for a HTTP API or REST API, and this will automatically create the API gateway for you and even deploy it. So here you can configure the security. So it's important to have some sort of security mechanism for your API gateway. Uh, Usually in production, you won't just deploy an API gateway directly without any security. For the purpose of this demo, I'll be keeping this open. We'll be also looking at other authentication options besides the two given here when we go into API gateway in detail. So here you also have the additional settings. So this is the API gateway name, the deployment stage. So this is something we'll be covering later, what stage means. what CORS means, and things like that. So you can also enable CloudWatch metrics and error logging. So for now, I'll keep this disabled. And you can also leave this option blank for now. So the API gateway has been created, and as you can see, it has even been deployed and integrated with the Lambda function. So if I click on this, as you can see, I'm getting a response from my Lambda function. So if you carefully look at the code we had already defined here, there are two things here, which is the status code and the body. So the status code here means the HTTP status code that you want to return in your response. So 200 means it's all okay, good. And if there is an error, you might want to return some sort of 400x response. So you can have different HTTP status codes here, and you can also define the response body. So here, if I go to that response, as you can see, this is the incoming event which was provided to the AWS Lambda function. So it has all the details related to the request. So what was the endpoint, what was the HTTP method, what were the headers of the request, and other such data. Uh, if I go back, so we can now view the API gateway in the gateway console itself. So since we created it through the like the API gateway through the Lambda console, it skipped a lot of configuration options. So we would go through each one of them and see what they mean. So when I open a REST API gateway, I'm given options to either create a method or a resource. So resource means basically you can see the path inside the API. So let's say I want to define test lambda. So I can define this path, and course is basically something that comes in when your API is being called through a UI based application, sorry, browser based application. So in web browsers, you need to have something called course headers in your responses to allow your API gateway to be called from other domains. So I won't go into detail now. You can research this a bit, but this is something which is used in browser-based applications. So here I can create a resource. So this has created a resource, but there are no methods defined inside this. You cannot actually call this resource. So I need to create a method. So the any method is like a wildcard. It would then handle all requests. Like any request which comes into this path would be sent to this integration. In this case, we would just define get instead of having any. By default, when we created the API gateway through the console, it automatically created a resource sample function with a method any. So any request which come into to the endpoint would be sent to the Lambda function. So here I can specify the integration type for my method. So here I can specify the Lambda function integration, whether it's a proxy integration or not. So this is quite important. When you define the integration as a proxy integration, whatever is in the request would all of it would be sent to the Lambda function. So as we saw in that sample response body, it was sending everything, the headers, the request body, everything. Instead of that, you can configure a non-proxy integration, wherein then API gateway would define how the request is transformed before it's sent to the Lambda function, and you can only specify specific parameters which need to be sent to the Lambda function. So it depends on your application and use case. which one you might want to prefer. But in terms of like if you just want to test how API gateway works, I would recommend using the proxy integration, which since it's simpler to configure. You also have other types of integration here. You can integrate with the HTTP endpoint. Even for HTTP, you have the option for having a proxy integration or not. You can have a mock integration, which means that there is no actual backend. API gateway itself sends a response. So this uh, is not something you would use often. It's only for in case of, say, a hard-coded response, like say you just want to send the same response to every request, or based on the request, if there is a simple transformation that you can do using API gateway mappings and transformation, then you can use the mock integration type. There are also a few other options here which are not as quite common as the previous ones. So AWS services, if you want to integrate with an AWS service API, and VPC link is so it's a very specific form of integration. So in case of REST APIs, it's to integrate with network load balancers, and in case of HTTP API gateways, it also supports application load balancer. So this is something you would rarely use. So for now, for our sample application, we would be using the Lambda function which we defined previously. So type here. So the name of the function was sample function. So I'll add that here. Click on save. So whenever you add a trigger to your Lambda function, you need to provide permission for that whichever service you are integrating to invoke your Lambda function. So if you do this via console, this would be done behind the scenes. You just need to click on OK. So as you can see, my method has been defined inside the test Lambda resource. But before we actually get to test this, so you can use the test option here to test it via the console. So this would give you the response from the Lambda function. But if you want to like actually use it in the deployed API gateway, you first need to click on deploy API here, and here you have to specify a deployment stage. So I'll demonstrate this now. So as you can see, I have deployed it to the default stage. You can name your stage anything you want. So as you can see in the URL here, there is a slash default added. You can create your own stages, like say for the same API gateway, you can have different stages. So you can have a dev stage, you can have a prod stage, things like that. So this can be useful if you want to use different versions of your API gateway. So here, for example, if uh, I can create a stage, then it creates another stage. So when I'm creating a stage, you are also given the option to select which pass deployment to use. So now my API gateway has two stages. So if I want to invoke the test Lambda endpoint, so I can do it this way. So as you can see, it's now able to return responses at the test Lambda endpoint. So I can share the link in the chat as well. I think Prithvi, you will be able to share the link in the chat, right? Okay.
Hello. Yeah, Kaustubh. We'll be sharing it.
Yeah, thank you. So this way you can view the response of the API gateway. So coming back, so inside the stage settings also there are various different options. I won't go into them in detail right now, but you have things like enabling CloudWatch logging, monitoring. You can export the API gateway definition as Swagger or Open API 3, things like that. One more important thing here is the authorizers. So here you can create two types of authorizers. Either you can create a Lambda function based authorizer or a Cognito based authorizer. So Lambda authorizers basically are executed for each and every request which comes in. So you can before the API gateway sends the a request to your whatever backend you have, it would first invoke this Lambda function, and it would use a token either from the request or either from one of the headers, which you can configure here. And that token can be used by the Lambda function to determine whether a invocation is correctly authenticated or not. You can also enable caching because so for the same user you don't want to invoke if you don't want to invoke your Lambda function again and again for each request, since it might become expensive, you can enable caching for a specific amount of time. You can also have some sort of authorization in the Lambda function wherein you can define the scope the user as, although that's a bit of an advanced feature. So the other authorizer provided here is quite simple. You just specify the AWS Cognito user pool. So Cognito is an AWS service which is used for authentication and authorization. So here you can specify the user pool ARN, and you can also specify the source of your token. So you can only source it from one of the header request headers, and Cognito would check that header whether the token in that header is valid and issued from that user pool, and then it would allow the request to go through. So generally when you deploy your application to production or like expose it publicly, you might want to configure a authorizer so that it's not directly exposed to the world. There are also few other options you can go through here. So things like say standard API gateway responses for, let's say like say a default 4x y-axis, things like that you can define here. Then you have the model. So this is something which might come up if you are not using proxy integration. Uh, in that such a case, you might be transforming the input and mapping it and things like that. So in that case, you can define models here. So by default, API Gateway creates two models for empty model, which basically has nothing, and error, which has a single message field. So there are also a few other advanced feature here, things like API keys, which you can restrict to use to restrict the amount of API calls made to your application in combination with users plans. But for now, we'll be focusing on this feature. So uh, one more thing which I had not covered in my Lambda console walkthrough. So okay, let's go back to Lambda. So in Lambda, you can specify different versions and aliases for your Lambda function. So you can publish a new version here. So this would automatically create a new version 1. So let's say. So this creates a version 1 of your function. So you can have uh, so you cannot edit the already published version. You have to go back to the main latest function and edit your code here and then create a new version. So this way you can have versioning for your Lambda function, wherein the same Lambda function can have different code and different versions. And one more useful thing here is alias. So you can create friendly names for your version instead of having 1, 2, 3. You can have a alias here. And there is one more useful feature here, which is weighted alias. So if you have multiple versions of your Lambda function, then you can specify those versions here and assign weights to each. So this allows for canary, like the canary deployment model, wherein you only send like a small percentage of traffic to a new version and to check whether that version is working properly or not. And once it has been verified, then you can move all your traffic to the new version. So whenever you create an alias, so okay, uh, whether it's an version or an alias, the function arn here would change slightly. So for this test alias, as you can see, it adds :test. And similarly for the versions, if I go to version 1 here, it would add this version here. So whenever you're specifying an integration, so let's say if I go back, give me a moment, I'll copy the Lambda function arn beforehand. So here, when I'm specifying the integration, so okay, in the console, you can also use the full ARN. Here you can specify the version of the alias. So as you can see, I'm changing the integration request here. I'm clicking on OK. And before I actually use it, I need to deploy it. Now, when I invoke this endpoint, it would use the version 1 for this sample function. And test lambda is still using the latest version. So if I suppose go ahead and change the code for the latest version, then the test lambda and the sample function responses would differ. So before we move on to the next topic, which would be Amazon SQS, are there any questions in the chat? Nope. Okay, all good. So, okay, I'll reshare my screen. You can view the API gateway documentation for the latest pricing. It depends on the number of requests and also the size of each request. So we'll move on to the next topic, which is Amazon SQS. So it's actually one of the very first services which was created by Amazon way back in, I believe, 2004, 2006, roughly at that time. So it's quite a simple service. Actually, it's a queuing service, and it's used to decouple applications. So suppose if you have application A and application B, and you want to send message from application A to B, or to invoke something, or like maybe process something, things like that, then you can easily put a Amazon SQS queue in between those applications. And this way you can decouple the applications, and the applications can remain independent. They don't have to integrate directly. So SQS is a fully managed offering from AWS for this purpose, wherein you can have a queue of messages. So there are two types of Amazon SQS queues. So the main focus of the session will be on standard queues. So these are queues wherein you are adding messages to the queue, and there is no order like guarantee that each message will be processed in order. So the numbers here mean which message was sent first. So the first message might be processed, then second, then the fifth message might be processed, then the third message might be processed, then the fourth message might be processed. So there is no guarantee on ordering. But for a lot of applications, this is still okay, because it's not like this duplication is happening frequently. It's not like this out of order uh, is happening frequently, because it still does a best effort to order your messages, and it basically follows at least once message delivery. So okay, there might be duplicates, but it won't be the case ever that your message wasn't processed at all. And this can be useful in applications like, say, the uh, image processing architecture that we discussed previously. So if you put, let's say, a SQS queue between your S3 and your Lambda, in case you want to like easily scale your Lambda processing. So in that case, uh, even if the same image is processed twice, and even if it's processed out of order, like say the image upload 1 millisecond later is processed before, it doesn't actually matter for the application. So in such cases, you can use the standard queue. But if you want to maintain order always, if you don't want any duplicates, then you can use the concept of FIFO queues. It also has message groups inside a queue, so you can group different messages in the same group, so that each group has maintains the same order and doesn't have any duplicates. So we will be focusing on standard queues, but it's important to note that FIFO queues exist, because like we can have questions in the exam where you're asked a use case where either one of these queues would work, but FIFO might be preferred because of some point mentioned in the question, or maybe standard queues might be preferred. So also obviously standard queues are a bit cheaper compared to FIFO queues, because FIFO queues have additional features. They have all the features of standard queue, and on top of that they maintain order and don't have any duplicates. So we'll be looking at Amazon SQS, doing a console walkthrough of it, and also integrating it with AWS Lambda. So I'll reshare my screen. So we can go to the SQS console now. So I can create a new queue here. So you can either choose a standard queue or a FIFO queue. You cannot change the queue type after it's created. This is important. Like you have to select the type during the queue creation. Unlike the other configuration options, it cannot be changed. So we have queue. Okay, so these are some important configuration parameters. So it's things like visibility, timeout, delivery delay, and all. So you can just click on the info tab here and see what each of this mean. So so visibility, okay, we'll be going through this in detail when I show the message, like when I send the messages and other stuff. So it's a bit easier to understand then. There are also other options here. So things like access policy, which decide who can access the SQS queue. By default, any authenticated user inside this account specifically is allowed to access. So that's the default access policy. You can change it according to how you want. You can even integrate with resources from other AWS accounts. Dead letter queue is something we'll be going through later. So I'll be covering it then. So yeah, I'll just create the queue first and we can look at the options. Okay, so as you can see, the queue has been created. You basically have to specify the name. And other configuration parameters, the default is set, you can change it according to what you want. So uh, okay, if I go to edit, so as you can see, almost all the options you can reconfigure it again. So as mentioned, this is a queuing service, so obviously this means that you can send and receive messages. So okay, I can send a message here, I can have any content in my message. Consent. So now my message has been sent to the queue. So when you are receiving messages, there is a concept called polling. So you can have either short polling or long polling. So here, uh, so usually in applications which use SQS, so the consumers, like based on how the configuration is done, you might be able to process multiple messages at the same time. So in that case, you can have a maximum message count which is more than one. So at one time, you can process up to 10 messages, and you can also set the polling duration. So this means that polling would wait for at least 30 seconds to like check whether there are at least 10 messages in the queue. If it reaches 10 messages, or if the 30 seconds pass, then the polling would stop. So when you use a long duration like 30 seconds, it's called long polling. Or if you use a shorter duration, like say 1 second, it would be short polling. So here I can poll for messages. So as you can see, the message I had already sent here, it was already I have already received it, but it's still polling, it's still in progress. So this is because I have set a polling duration of 30. So it would wait for 30 seconds to check, like in case I send another message here. So as you can see, it receives that message. So that's why, like in cases where you might want, you can afford to wait and you want to process multiple images, you can set a longer duration. Otherwise, you can set it to a shorter time frame and also change the message count according to your requirements. So when I receive a message, there is another option here which is called delete. So this is quite important when consumers receive messages from SQS, they need to delete the message. Otherwise, that message would go back into the queue. So this is essentially an acknowledgement from the consumer that the message was processed correctly and it doesn't need to be processed again. So if I poll now, as you can see, there are no messages coming in. So I can just stop the polling for now. Yeah. So there are a few configuration options that we had looked at here. So if I go into edit, so okay, visibility timeout. So this is important. So it's basically the amount of time. So suppose I receive a message, then the consumer has 30 seconds to send a delete message acknowledgement. So if acknowledgement isn't sent inside 30 seconds that the message can be deleted, then the message would be put back into the queue. So it's important to have a proper visibility timeout according to how much time it would take to process the message. Otherwise, you might be end up in a situation where you're processing the same message multiple times, even though the message was actually already processed by some other consumer. So it's important to configure this correctly. And message retention period. So this is the amount of time your message stays in the queue if there is no consumer picking this up. So this can be a maximum of 14 days. So if I send a message and then I don't receive it at all, if I don't do anything, the message would still remain in the queue for up to 4 days or whatever time period you configure. It can be in seconds as well. Or that's minimum of 1 minute. And just a second. Yeah, sorry about that. So you can also have a delivery delay. So after you put messages in the queue, uh, so this is the amount of time like the after which your message would be visible. So okay, I'll go back to the other configuration options. So apart from the basic configuration option that we saw, there are a few other things as well. So I'll cover the important ones. So dead letter queue is something important. So here, uh, if suppose your messages aren't getting processed correctly, so after a set amount of like attempts, it would enter the dead letter queue. So this can be useful. Say your consumers are not working correctly. Suppose your Lambda function has an error, or maybe that particular message has something which causes errors when we try to process it. So in that case, those messages would end up in the dead letter queue. So this is essentially another SQS queue. You have to create another SQS queue and add it, configure it as a dead letter queue, and that would have all the messages. So later, someone can check the dead letter queue and reprocess those messages. So that uh, option that we saw for message retention period, that's especially crucial in the case of dead letter queues, since messages might stay in a for a long time in a dead letter queue. So you can also configure Lambda function triggers. So so the Lambda function which we had configured earlier, you can select it here and click on save. So this would error out now. So this is because for the SQS trigger, the Lambda function needs specific permissions for its IAM rule before we actually assign it or like use this queue here. So I'll just go back to the Lambda console. Okay, I'll add the policy for the SQS queue manually. So uh, I can illustrate what permissions you might need to add and things like that. So here I go to, okay, this error is coming because we changed the version for this endpoint. So that's why it's saying not found here. So if I go to, so this is the AWS IAM console where you configure the roles and the policies for it. So here, as I'd already discussed, there are a few specific policies which allow you to create logs from your Lambda function. So we will be adding one more inline policy here. So this is for the SQS service will be doing it. For now, we'll just add all actions to keep it simple, but this is not required. For the Lambda function trigger, you don't need to add all SQS actions. You can also specify the QARN. So in that case, it would the Lambda function would only have access to that specific SQS queue, which is the recommended practice. For now, I'll just skip it all resources to make it simple. But in an actual use case, you might want to narrow down the actions and the resources for your IAM inline policies or any policy you create. So I'll just give a name here. So now SQS permissions have been added to the Lambda function. Now if I go back, if I configure the Lambda function trigger here now, as you can see, it worked correctly now. So it would take the few minutes to create. We can wait for that. So till then, okay, there are no questions in the chat. If you have any questions, you can keep on posting them even while I'm explaining. And once I'm taking a pause anywhere, I'll come back to those questions. Okay, so the Lambda trigger has been created. So if I send any message here, okay. So if I go to Lambda now, we would see that the Lambda function would have executed. We can check the logs for this. So this is also another important thing with Lambda. Whenever there is a execution, we can view the logs in CloudWatch. So you can either view them through here, or even better, you can just go to the CloudWatch console, since that would allow you more options to filter and sort. So I can, as you can see, there is an execution at 15:59. So when you send the SQS message, as you can see, uh, it sends the SQS message to the AWS Lambda. So one thing you would notice here, earlier I had mentioned that the consumer needs to delete the message from the queue. But if you look at my Lambda code, there isn't anything which actually deletes the message. So this is because in the case of AWS Lambda specifically, AWS deletes the message directly for you behind the scenes. In case your Lambda function doesn't have any run into any exceptions or error out. So you don't need to manually delete the message for SQS from Lambda. But any other consumer that you use, like say if you write custom code on your EC2, or let's say any other place, then you would need to make sure that you're deleting the message. Otherwise, the message would get processed again and again until it reaches a deleter queue, or if you haven't configured it, it would just run infinitely. So if I go to the queue again, so there are a few other options here. We have SNS subscription. So SNS would be our next topic. Then that later queue we discuss monitoring, tagging, which is basically the same thing we have with every AWS service. Access policy, encryption. So you can have server-side encryption for SQS, and you can specify whether a queue can be used as a dead letter queue, and then you can have something called retrieve task. So any messages which are in here you can reprocess them. So I'll stop sharing and uh, go back to the slides again. Okay, I see there is a question by Ramakrishna, how to monitor the queues, whether messages are received or if there are any messages in the queues. So in the AWS console, we have the monitoring options. Okay, I'll go back there. Yeah, as you can see, there are you can monitor your SQS message, like SQS queue here, how many messages were deleted, what was the size of message, number of messages sent, all types of parameters you can view through here. If there are any messages which are not being processed, you would also be able to spot it from here. So this provides you the granular level view. Okay, coming back to the next topic. So for SQS pricing, you can view the documentation. So obviously it depends on the number of messages you are sent and other details. So, okay, next service we have is Amazon SNS. So this is a fully managed messaging service. So it provides application to application integration or application to person communication. So we'll see what exactly this means in a moment. And it can be also thought of as a distributed pub sub system. So if you're familiar with the term pub sub, you might be able to link it with Amazon SNS. So we'll be looking at these terms: publish, subscribe, and so on when we do the demo for this. So, okay, this is a sample architecture for Amazon SNS. So you create something called a topic inside SNS, and then you have publishers which publish messages to that topic. So that's where the pub part of PubSub comes in. You have publishers which publish messages to SNS. So uh, the difference here from Amazon SQS comes in that the messages are sent out to subscribers. There is no queuing here or anything like that. You have different subscribers here. So it can be a variety of different AWS services or other types of external services, or it can be things like email or SMS. And all subscribers are sent a message, unlike SQS where it's processed only once. Messages are sent separately to all subscribers. So as you can see, like you can use SNS to publish SMS, send SMS to different users of your application. So I'll go into the demo for this. Just give me a moment. Okay, there is one more question from Ramakrishna. How to create? Okay, how to create SQS queue cost optimized way, and can we see the history of sent messages? So okay, okay, I'll address the first question. Uh, so SQS, when you create a queue, you aren't charged for the queue itself. You are only charged for the messages you are using. So by default, you can think of it like there is no like inbuilt cost optimization, like say in EC2, where you can choose the instance type and things like that. There is no like direct cost attached to just creating a resource. It's just based on the users. So to cost optimize it, you have to minimize your users, and you also need to properly configure the queue. So the things like visibility, timeout, and all, you need to make sure that the same message isn't being processed twice, and avoid such an issues like that. And that's the way you can optimize your SQS cost. In general, SQS is like one of the cheaper services, I would say, in AWS compared to like other parts of your stack. SQS probably won't have as much of a cost. And can we see the history of sent messages? So you can view the like as I said, you can view the number of messages which were sent, and you can track it through the CloudWatch metrics. And if you want to like see the contents of the message specifically, you can do some logging at the sender or the receiver end for that. Okay, I'll reshare my screen and move on to Amazon SNS. Okay, I can first you will need to create a topic in Amazon SNS. So here I just click on create topic. So even in SNS, you have the option between standard and FIFO, but FIFO is rarely used in practice because you can only subscribe with SQS, as you can see. Sorry. For standard topics is the most common use case, and that's the most widely used. So here I can just, and one more note, like for obvious reasons, when you use a FIFO as SNS topic, the SQS queue also needs to be FIFO. It cannot be standard. So okay, and so this also has similar options to SQS, where you can have server-side encryption. You can have access policy. So by default here also, it's only accessible to the AWS account, which is the owner entity described. Then for so this is for any HTTPS endpoints you are configured as a subscriber. You can have a retry in case, like, say the HTTP endpoint is failing for a few requests, maybe it's struggling to scale or something like that. So in that case, you can have a retry policy. So there are also some other options here. I won't go through them in detail now. Yeah, so that's it. You just create a topic, and you can create different subscriptions here. So okay, I'll create a subscription. So as I mentioned earlier, there are a variety of subscriptions you can have. So this is the basically determine the protocol type here. So you can have email based subscription. You can have SMS. So that would be A2P, that was mentioned in the first slide. So application to person. And if it's something like, say, AWS Lambda, then it's A to A, application to application. So here I'm doing application to application. So I'll just the line of the Lambda function. Okay, I've added the Lambda function here. I'm creating the subscription. Here, as you can see, like you can view the all the subscriptions you have in your account, and the protocol and the topic. So subscription, one thing to note for SNS subscriptions is that they need to be confirmed. So for Lambda, like any AWS service, this like process is done automatically. But in case of, let's say, if you're adding an email here, for example, or say, let's say a SMS subscription or something, then whoever owns that email, or like whoever has the owns that number where you are configuring the SMS subscription, they would need to confirm the subscription. Otherwise, the messages won't be sent. So here, okay, if I go to the topic, here I can publish the message. So I can have subject for my message, subject. And you can have the message body. So one thing to note is, for each protocol you can have a different body. Let's say for like Lambda, you want this to go. For SKS, you want this. So if there is any SKS subscription, then it would receive this message. If there is any Lambda subscription, it would receive this message. Alternatively, you can just have the same message for all delivery protocols. So the same raw message would be delivered to all subscribers. So I've sent that message. So unlike SQS, there is no like message receive or pooling for message or anything here. Whatever subscribers are there, the message has been sent to those subscribers. So if I go and view the logs of my Lambda function, so here, as you can see, there was a execution at 16:13, and this was the event received by the Lambda function. So as you can see, you have the subject, the message attributes, we did not add any attributes to the message, so that's not there. And we have the message body as well, sample message. So okay, I'll move on to the next part. Reshare my screen. I see there are no questions so far, so I'll move on to the next part. Next, okay, so this is just a quick slide to again go through the difference of SQS and SNS. I talked about it a bit, but let's go through it in a bit more detail so it's clear. So SQS has a pull mechanism wherein you're polling the SQS queue. So consumers poll the SQS queue, while in SNS the topic, like the SNS topic itself, pushes the messages to all the subscribers. The subscribers don't have to poll the queue for messages. So this is also why for Lambda you need to add the permission for to be able to access SQS, while for SNS you don't have to do that since the topic itself will push the messages to the Lambda function. Next we have the center entity. So obviously for SQS it's a queue, for SNS it's a topic. For SQS, so the typical use cases, all messages are identical and all messages are processed by same type of consumer. So let's say the image processing example that I gave, you can have a fleet of consumers. So it can be, let's say, a fleet of EC2 instances which is doing the image processing. So all of the EC2 instances would be usually identical. You would be processing the messages in exact same way because each message is processed only once. So it's not like you can process the same message in 3 different ways. But in SNS, that's not the case. For each message, you might process it in a different way based on the subscriber. So suppose image is uploaded and an SNS topic is somehow notified on the basis of that. So the SNS topic would send that message to all subscribers. So let's say there might be a Lambda function which would create different sizes of the image. Then there might be SQS queue, which is let's say consumed by EC2 based application, and it does some other form of processing, like say validating the image, whether it's correct or not, things like that. So each subscriber might process the message differently since each one of them is processing it separately. So also another important difference is that SQS queues have persistence. You can process the message at a later point as well. While in SNS, there is no persistence. Like once the message has been sent, it is automatically sent to all subscribers and it is not resent. There is no, like unless you look at the HTTP endpoints retry policy. Apart from that, there is not even a retry. So they are directly pushed to the consumers. There is a option for a dead letter queue, but it's actually a SQS queue. If I go back here, there was a SQS queue. This was actually a SQS queue, which if messages are failed, like it cannot be delivered. So for some reason, then they can be sent to a SQS based dead letter queue. So apart from that, there is no persistence in SNS. So again, for SNS as well, pricing depends on the like amount of messages you're sending. So it's basically on the basis of the API calls you're making, and also it depends on the type of subscribers. Because let's say if you have a email subscriber or a SMS subscriber, so for each subscriber type, the pricing would slightly differ because obviously the cost of sending a SMS and cost of sending an email is different. So that's why AWS has different prices for different types of subscriptions. So before I move on to the next topic, okay, there are no questions. Okay, next we have AWS Fargate. So, okay, so this is basically serverless but with Docker containers. So there was a question earlier in the session uh, where someone was asking how you can combine serverless with Kubernetes. So we sent a link of AWS samples. So this is basically a huge repository with a huge number of code samples and sample architectures and all. So, uh, but for the specific use case, you can combine EKS, which was a service we discussed yesterday. It's basically a managed offering for Kubernetes, and you can combine that with Fargate, which runs your containers in a serverless manner. So this is something which is compatible with both ECS and EKS. So without Fargate, you have to like deploy your containers on EC2 instances. So whenever you create a ECS cluster, you can let's say attach a number of EC2 instances with that cluster, and on those EC2 instances, your containers would be deployed. Similarly, for Kubernetes clusters, you can have a fleet of EC2 instances on which you run your pods. But with Fargate, you don't have to, you skip the part where you have to deploy your EC2 instances. Instead, you can define your memory and compute requirements, and you can automatically run and manage your applications. So this way you only pay for how much memory and compute resources you require, and you don't have to manage a fleet of EC2 instances. So it's not as like say pure serverless as Lambda, because you still need to have some sort of memory and compute resource defined, and you would always be charged for that much. But it's still like much better than having to manage a fleet of EC2 instances, the instance type, and so on. So it might be a better option based on your use case. And obviously you can also auto scale the number of containers you require on the basis of incoming traffic. So that's another advantage with Fargate. So okay, I'll reshare my screen, and for Fargate we won't be starting from scratch. I've already deployed a task in AWS Fargate, so we'll be reviewing that. So go to ACS in the region. So as you can see, like we have a ECS cluster already running here. So I'm demonstrating integration of Fargate with ECS. So whenever you like launch a task here, say let's say run new task, you can specify the launch type either Fargate or EC2 or external. So external is basically if you want to run your ECS task on an on-prem system, or EC2 is obviously the conventional option where you are deploying it on an EC2 instance. On Fargate, you are deploying your uh, basically task on a like a serverless way where you don't define the EC2 instance or any other requirement. So there are other options here. I won't go through this now, but you can like specify the networking options, and you have also have something called task definition. So task definitions is a general term, as in even for EC2 based tasks, you need to have a task definition. So you specify a different bunch of parameters here. You define the container image that you want, and so on. And if it's when you're defining a task, you can specify where exactly that task is compatible. So here for this task, it's able to run on both EC2 and Fargate. So uh, here, as you can see, when I'm defining the task, I have specified the memory and CPU, since this task would be running on Fargate. And if I go to the cluster, I have already defined a task based on the task definition. So here, this task is already running, and so I specified different parameters here. So you can also access this task to this public IP. So if I go here, you can say it's already running. So this way you can define your task. Obviously, you can also use services, which is usually the recommended way to create tasks, so that like all your needs of scaling and everything are provided through the service. And you might also want to attach a load balancer or something like that if it's a web application, or like if you need to expose your application publicly, you can expose the public IP of your task, but generally it's recommended to expose it via a public load balancer, so it's safer to use in terms of security. So one important note here, and this is very important, but Fargate doesn't have a free tier. So if you're testing this, you might get charged. So before you jump into any console demos with this, make sure that you are aware of the pricing. Uh, if you run a minimal task, you won't be charged much, but be sure that you are comfortable with being charged before you actually try to test Fargate. Okay, I'll reshare my screen. Yeah. So, okay, uh, so that was it from the demo side and everything. There is one small last service we will be covering before we close the session, which is Amazon Kinesis. We won't be going into detail here, but we'll be just looking at a few important points for the examination. So first of all, Kinesis isn't actually one service. It's like four different services, to be honest. So in general, I would say the general definition is what's given here. You're basically have a stream of data, and you can like analyze it or collect it or store it, process it, or like basically do things with the data stream. So that's a very high level general definition, but there are actually four different things, like four different services inside Kinesis, and it's important to know the differences between them, because you might be asked questions in the exam where you need to tell which Kinesis service you want to use for a specific use case. So for Kinesis video streams, it's simple. You have video streams, and those video streams are processed by Kinesis video streams, and they are sent to different consumers. So it can be Amazon SageMaker for ML analysis, Amazon recognition video, and things like that. You can also have your own custom video processing or other things using Kinesis video streams. And next you have Kinesis data stream. So this is a bit more general. So instead of having streams for video data specifically, you have data streams, and you are ingesting and storing data streams. So this means that whatever data stream is coming in, it's sent to different consumers. So it can be compute resources like say AWS Lambda, Amazon EC2, even Spark. You can run that on EMR or any way you want, and you can even configure it like through with another Kinesis service, Amazon Kinesis Data Analytics. So even these services might integrate with each other based on the architecture we have. So the data stream would be processed by these services, and they would give you the desired output. So data firehose is slightly different. So instead of processing your data, it's more of like storing that data in a persistent storage. So things like say S3 or Redshift or Elasticsearch, and then you can perform your analytics on that stored data using other analytics tools. So last, we have Kinesis data analytics. So this is something we already discussed. So the streaming data which comes in from, so it can come from Kinesis data streams itself. It can come in from Kafka or Amazon MSK is basically Amazon's managed version of Kafka, and things like that. So whatever the source is, you can send it to data analytics, and it just allows you to run queries on the data streams. So this is mainly used for analytics, machine learning, and other forms of stuff. So this is the important slide. Like if you are focusing on this on from an exam point of view, this is the main thing you would need to know. Although I would highly recommend to at least go through some documentation for each service so you have a better idea. But so video streams is basically, as I mentioned, the keyword here is video streams, video. So it would be capturing, processing, and storing video streams. Data streams is same, but it's general for all data. Firehose is different. You are not like processing the data. It's more of loading the data, and any processing is done later on those data stores that you have. And last, we have data analytics. So as I discussed, you can analyze your data streams running SQL like or Flink queries. So I won't go into the pricing for each. You can go through the documentation for this, but each service has its own unique pricing model. So each of them has a separate documentation, has a separate pricing, a separate everything. So even though the name is same for each, make sure that like you need to understand that these are essentially different services providing different use cases. So, okay, this slides is like more of a reminder, but whatever we have covered today, make sure that at the very least, obviously, I would highly recommend you to go through the documentation of each service as and when you're learning it. But at the very least, you must be familiar, like go to the FAQ page for each service, because like a lot of the basic details of the service and common questions you might have for each service are covered in this FAQ page. So I would highly recommend to go through the FAQ page of each and every service that we discussed today and even in previous sessions. So yeah, like that's it from my side in terms of the content. And I would like to thank everyone who was a key member in terms of organizing this session. And yeah, that's it from my side. Are there any questions we have in the chat?
Uh, yeah, actually, the question is from Ram Krishna. Can we see the history of the send message? I think that's
Yeah,
covered earlier.
yeah, already answered that. Yeah,
Yeah, yeah, okay, okay. So no questions, Kaustubh, as of now.
yeah.
So before we end up the session, I would like to thank you for the informative session on AWS Lambda, SNS, and other AWS services. Okay. So hello, if anyone of you is there, if anyone of you are here and not registered for the session or for the boot camp, we will provide you with the link so that you can register with the boot camp. Okay. If you are not there in the yesterday's session on AWS Compute Services, we'll provide you with the link. No worries. We'll share it via the mail. And last but not the least, we will have the session on database and storage in next week. So stay with us for the next 5 to 6 weeks. Thanks a lot, everyone.